Hi guys, welcome again to this short video series. In today's video, I'll be talking about 2019 Standard Maths exam question number 30. This question came from one of the newer topics, which is the topic of network. So let's open that. And the question itself is this question number 30. Now you're given a network diagram, and then what it's asking you to do is draw a minimum spanning tree in the space below. Now to know how to draw the minimum spanning tree, I have put down all the examples and all the theory that you need. The way to work on this is there are two ways to work, which I talk about in the algorithms. And there's Prim's algorithm, and then there's this one, Kruskal algorithm. I'll be working through this algorithm in this example, which is I feel is the easier way to go about it. So follow along how I do. So let's take out this question. There are two parts to it. We're going to deal with the first part first. So the way to go about this is you draw the full diagram. So I've just copied this one over here. And we start working out those paths that are shortest. And then if at any point we reach a point where we are making a cycle, and I'll tell you what the cycle is, we're going to ignore it. So let's start with this diagram and it'll be clear. So from all of these, the shortest one is G to F, right? It's got 1. So we're going to select this. So this is okay. Then the next shortest is here, G to H. So let's select this. And then the next shortest is this one. So we'll select this. Now here is where a cycle is complete. G, H, and C. There is no need for this one. Why I say that? Because you can reach each of these points without having a need for G and C connected. If you reach any situation, ignore that. So in this case, a cycle was completed. That's why we ignored. So next one that is smallest out of all of these is A to B. So we select this one. Now the next one is 5. So you have a choice which one you select. So let's go for this one. Again, 5 is still the shortest. So we can again choose out of these 3. So if we choose this one. By the way, there is a cycle that's being completed over here. So we're going to ignore this one. Then next is either you can choose this one or this one. So if you choose this one, you can ignore this and ignore this because the cycle is completed here. And again, with this, the cycle is again completed, so we don't need to consider this because you can reach each and every point without having a need for this connection. If you are here, you can reach H, G, and F, or if you're here, you can reach anywhere. So that would be your diagram. So the question is then asking you minimum length. So the minimum length would be the sum of all of these. So 4 plus 5, 9, 9 plus 3, 12, plus 2, 14, plus 1, 15, plus 5, 20, plus 5, 25. So answer to A is 25. Second, it's asking is that on a given day, the track between C and H is closed. So what it's saying is, say you can't access this doesn't exist. Then state the vertices that identify the shortest path from C to E, right? So for this, let's list down all the paths that connect C to E. So the first path is C, G, H, and E, right? C, G, H, and E. And what's the total value? 4 plus 2, 6, plus 5, 11. What's the next path? C, G, F, and E. C, G, F, and E. And this one is 4 plus 1, 5 plus 7, 12. And what's the next part? C, D, H, and E. C, D, H, and E. So that would be 7 plus 5, 12 plus 5, 17. Next one is C, D, and E. 7 plus 5, 12. So out of all these, the shortest path is this one, C, D, H, and E, which takes 11, value of 11.